Alright, so if you have log y equals log base b of x. Okay, when you're exchanging forms, so you're going to be going from log form to exponential form, and exponential form to log form. You're going to be going back and forth. So depending on what type of math you're doing, you may use exponential form or log form. So you're going to have to be able to switch back and forth between exponential form and the log form. Logarithmic, log is short for logarithmic, so you may, whenever we're talking about logs, LOGs, we're talking about logarithms. So what that means is you're going to have to be able to convert from something we just got done doing, x equals b to the y, to this over here. Well, if you convert from what's on the left to what's on the right, you need to add a log, don't we? You need to add a log. If you notice, from this form here to this form over here, in your exponential form, don't you have a b to the y here? But over here you have a y all by itself. So what did you get rid of here? To go from here, from this b to the power y to a y. What letter did you get rid of? You got rid of a b. So this b, what it does is, this b actually moved down in front of the x, didn't it? So this b is going to move down here, if you want to convert from exponential to log form. It is a base, whether it's down on the bottom of a real tiny number or if it's a big number. And then what you do is you just say the log base b of x. It's a way to rewrite this. So I found some kid's handwriting or whatever. Flippy and floppy. You can only take logs of positive values. Now, so everybody like, what in the world's a log? Well, basically a log is the answer, it's an exponent. So if I ask you what number, if you raise 2 to what power to equal 8? 3. 3 is the logarithm of 8. If I know 5 to what power equals 125? What's your power? 5 to what power equals 125? 3. So your logarithm would be 3. This will make a little bit more sense here in a little bit. But a lot of people get really confused with logarithms, like, oh my gosh, I see an LG, I don't know what I'm doing. You're just finding an exponent, is what you're finding. So here for example 1, what we're going to do is we're going to convert from log form into exponential form. The only thing we said before that moved was our b. So if this is your b down here, this 3 is going to move over, and all it does is bump up this 2. So you get a 3 squared on the right. On the left, the log cancels out. So you just have a 9 equals 3 squared. Is that a true statement? Is 9 equals 3 squared? Yeah, so we didn't make anything untrue, we just rewrote it in exponential form. So do the same thing on A. This 10 right here. This 10 is going to move up and under the -2. So you get a 10 to the -2. Log cancels out and you get a 1 over 100. Is 1 over 100 equal to 10 to the -2?
Yeah.
So that's a true statement still.
So you just leave it like that? What's your answer?
Yep. When you're converting from log to exponential form, yes.
If it's the same, you don't have to like write it like 3. Like you have to simplify the 9.
Oh man, you are getting ahead of us. Kenzie, you can see into the future.
Yeah.
You must be able to see into the future because that's how we're going to solve our problems when we get to example 3. Now, is 4 to the 5 halves equal 32? I don't know. 4 can be rewritten as a 2 squared, correct? So what happens with the square and the 2 on the outside? Cancel, just stop.
Fail. We're answer the question. It wasn't a question.
Yeah, it wasn't a question. Fine.
Yes. Now he's out.
Bucks.
Now he does.
So in this A2 squared.
Cole, shut it. I can say that now. You're a noise. Like more than I am.
All right. So what happens? All right, up here, up here.
Your face is
What happens with these 2's? Those cancel, so you get a 2 to the 5th, which is equal to 32. So isn't that a true statement? So 4 to the power of 5 halves is equal to 32. Actually, like what? Can you multiply this 2 times 5 halves? So then that means those cancel. Which means all you have left is
I didn't do anything.
2 to the 5th power. So 2 to the 5th equals 32.
I want $5.
So you get a 1/9 equals 3 to the negative 2. Is this a true statement? 1/9 equals 3 to the negative 2. Is that true?
Yeah.
That's true. All right, now notice the only thing that moves is your base. Right? The only thing that moves is our base. So if you want to go from this exponential form back to log, we're just going to take this 3 and move it back down here where it just was. That's the only thing that moves. So you're still going to have this. You got this little 3, this 1/9 equals negative 2, but where are you going to put in front of this 3 and this 1/9? A log. So if you go backwards, what's the only thing that's going to move? The 5, the 3, or the 125?
5.
5. 5 is going to move down. It's going to become smaller. So you're going to have a 3 on the left. You have a little 5 here and a big 125. What goes in front of the 5 and the 125? Log. Now this is a true statement because if you have to find the log of base 5 of 125, your answer is an exponent because you're trying to find 5 to what power equals 125? 3.
How do you write that in your calculator?
Ha, good question. Some people are going to be like, oh man, when I saw this, I'm just going to type in the log of 125. And then we're going to spit out. It's probably going to spit out a 3 for me because that's what calculators do. They're real nice. Find the log of 125 on your calculator. See what it spits out.
2.09. I got 4.8.
You put LN, not log.
It's 2.1, right?
Yeah.
You put LN.
That's not equal to 3. That's not equal to 3.
Because it was funny.
All right, both of you, just don't talk to each other, period. It'd be great. So that's not a 3, is it? Your calculator only finds a log with a base of 10 down here. So on your homework, when you have to find the log of like 243, and you can't just type it into your calculator to find it, you have to convert this to from this form back up to here to find out what your answer is.
Is there a way?
Oh man. Ryan, you are on top of things today. Good for you. Only thing it's going to move is 27. Only thing it's going to move is 27. So you have a 1/3 over here. Equals, you have this little 27. A big 3. What goes in front of those? Log. Yeah? No. I'm just showing you that it's equivalent, that it makes sense.
I know, but like, is there going to be any ones that are wrong? Like that?
You'll have to do it on Thursday. You won't have to do that today. What moves? 7. So you get 3 equals the log base 1/7 of 100, or sorry, 1 over 343. What moves on D? 81. So you get 1/2 equals the log base 81 of 9. So what this is saying is 81 to what power equals 9? That's how you have to read it. I know it's kind of a weird way of reading it, but that's all a logarithm means. You're finding an exponent. If I take 81 to the 1/2, and if you have something to the 1/2 power and that's the square root of it, so isn't the square root of 81 equal to 9? Yeah. All right, now let's get to what Mackenzie was talking about. She's like, I think I know how to do this. Don't you do this? Blah, 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 blah. And I said, yes, you are so smart. You are so smart. I'm also nothing. Nothing. First step, you have to set this equation equal to x. We're going to evaluate this now. Set it equal to x. Second step, rewrite in exponential form. So you're going to go from log form to exponential form. What do you move? Move 3. Log cancels, so you have 243 equals 3 to the x. Hey, we've done this before. He's not the only smart one in class. Cameron's on Fuego today. In Fuego, not on Fuego. If this has a base 3 on the right, then that probably means we could rewrite 243 as a base of 3. Huh? So this is a 3 to the 5th equals 3 to the x. So what's x equal? 5.
How'd you get that?
How did I get what? I know my powers. That's how I got it. So is Jaden.
Oh, okay.
243 to the 5th, or 3 to the 5th power gives you 243. This is your little hint over here, because this can't be reduced any further. So since that can't be reduced any further, then that means this has to be reduced to 3 to some power. Okay. Next one, let's do B. Set this equal to x. What slides over? How do we get rid of our log?
Can you just type that in your calculator?
This one, yes, you could cheat and put it in your calculator. 10 moves over, so you get a 1,000 equals 10 to the x. 10 to what power equals 1,000? Oh, what do you have for a calculator?
Thank you.
She's back. Oh, give it to her now. 10 to the 3rd equals 10 to the x. So what does x equal?
3.
3.
It's easy. Where's the arms?
Set it equal to. Set it equal to x. 1/2 moves over. So you get 256 equals 1/2.
Mr. Kline,
Yes.
on the one on B, is it 3 is equal to x because like 3 is like the
Exponents?
yeah.
Yes.
Okay.
Remember what we did last time? Once you get the common bases, you can set
So
your
whatever
exponents.
the exponent is, that's what x equals.
You have to set them equal to each other, yes. As long as you have the same base, then yes.
Yeah, that's what I meant.
Yeah.
Okay.
All right, now, these don't have the same base, but the one on the right kind of gives you a little hint. If you have a 2 in the denominator, you need to move it up to the top. So this becomes 2 to the
Negative x.
negative 1. Negative 1 times x gives you negative x. So that must mean 256 can be written as 2 to some power. 2 to what power gives you 256?
8.
2 to the 8. Now, what do you set equal to each other? Well, we're going to say
8 or negative x.
8 equals negative x. Divide each side by negative 1. X equals negative 8. And x equals negative 8. Okay? Last one, letter D. What slides over?
4.
4. So you get a 1 over 64 is equal to 4 to the x. Can 64 be written to 4 to the power?
Yeah.
4 to the
3rd.
3rd, and we got to move to the top, so we're going to get 4 to the negative 3.
How do you get negative 3?
Because
The bottom you want to
on the
Yeah,
top.
since it's on the bottom, we want to move to the top. Because this is really equal to a 1 over 4 to the third.
Yeah.
But we can't leave that 4 to the third on the bottom. So what's x equal here? Negative 3. So it is pretty similar to what you did for your homework for today in some aspects. Yeah, the only thing that's different is you have to convert from log form to exponential form. And then it turns out just like what you did. So if you did okay on today's homework, then hopefully you'll be all right on tonight's homework. All right, so that's where you evaluate. Now, we are also going to do a little graphing. Back in college, you used to call me Sir Graphs a lot, so we gotta keep this going. We'll be graphing. All right, Jake? Sure. All right, now, like we said before, if you have an inverse of a function, the log function is the inverse of an exponential graph. So remember, for inverses, they both reflect over this line here, going through y equals x. So if you were to fold this graph on this line, fold it over there, you're going to end up and get the same line. Well, that's how you find inverses graphically. Algebraically, don't your domain and range reverse? Do they flip?
Yeah.
So if our domain for our exponential functions was all real numbers, what's going to be our range for these log functions? All real numbers. So your range, down here on number 4, is a set of all real numbers. Now your domain used to be all real numbers, but now if you look at your graph never stops going to the right. How far does it go to the left? It gets closer and closer to 0, but it never touches it, does it? Never touches it. It gets here and it gets closer and closer. So what happens is your domain is going to be all positive real numbers. Or another way to write this, you could just say that x is greater than 0. And you could also say x is greater than 0. So if x is greater than 0, that means it never touches this line. And that means this line, you have a vertical one of these. When we had our exponential function, we had a horizontal. What did we call that? You may remember what? Starts with an A. Not axis.
Oh, it was weird.
Yes, it is a weird.
Asymptote.
Asymptote. Very good.
Wow.
A S Y M P T O T E. Asymptote. P is kind of silent, unless you want to really emphasize it. Asymptote. 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 All right, so that means that your graph never touches that line there. So let's go ahead and graph these. Now, when we graphed exponential functions, we would just type in -2, -1, 0, 1, and 2. Well, unfortunately for these, we can't do that. We can't just put any number we want. So the numbers you do want to put in, though, that's a Captain Picard. You didn't have to see the Saturday Night Live story.
Who is that?
It's Captain Picard from Star Trek.
It's okay.
And Dr.
And
Xavier.
Captain Clark.
So your x values for your table. Always. Yep, I'm done. You're good? Okay. Always use a 1 in your table. And powers of the base. Huh? What? School of Hard Knocks.
Purdue.
Which is a lie.
Which is Purdue.
Pretty tough.
It's a hard knock.
It's pretty tough when I went there.
It's even tougher now.
A lot of people like to eat each other up. So. All right, our x values. So what we're going to do is we're going to plug in a 1. Always use a 1. And I'll show you why in a minute. You're also going to use powers of the base. So if our base is 5, well, 5 to the first power is just 5. We're going to plug a 5 in. 5 to the second power. 5 to the second power is a 25. 5 to the third would be a 125. These are the numbers you're going to plug in for your x. The reason is, otherwise you're going to get decimals. And you can plug in other numbers, but you don't know how to plug them into your calculator to find the correct numbers yet. So no point in putting other numbers in. Oh, all kinds of little children's. All right, so here's why we plug in an x. If this is your equation, y is equal to the log base 5 of 1. So if we want to solve this equation.
Good afternoon to Kline High School. This is Mrs. Burnfield with a special announcement.
All right,
Today
this 5
across the
moves over.
central United States, people from all walks of life and several school corporations and hospitals and facilities all practice the Great Central United States Shakeout.
So
If you remember, we
5
practiced
to what
this
power
last
gives you a
year.
1.
It's just a reminder about earthquake
0.
preparedness.
So you plug in a 0.
FEMA
So you go
has
over 1
recommended
up
that
0.
rock, cover, and hold on in case of
that.
earthquakes. Earthquakes are not something you get an alarm for. It's not something you can look out the window and see coming your way. They're an immediate happening. So remember, wherever you are.
X value, plug in an X or plug in a 5.
Earthquake.
The reason is if you plug in a 5 over,
Cover your
if
head,
this 5
hang
moves
on.
over, bumps up the y, you
But
get
also
5 to the
begin to
y
look around
equals.
at your surroundings. Are there things
5,
that
what's your
fall,
y equal?
Things that need to be secured to the wall?
What's your
Not
y
only
equal?
where you're at
1.
school, but maybe at work.
So what you do is you go over 5
And then,
up
are you prepared?
1.
Not just for an earthquake, but for a tornado?
What if you
blizzard,
plug in a 25?
Whatever conditions may befall the area where you live. You're all welcome to go on to
Plug in 25 for your x.
or the
So you
Great
get
Central Shake or Great
5 to the y
Shakeout.org.
equals
You
25.
can find
5 to
all
what
sorts
power
of
gives you
information
25?
about how to get prepared.
She's making that.
2.
This time.
So what you do is you go to the right 25 and you go up 2. Uh-oh, that's not going to fit on our graph, is it? Over 25, up 2, little dot. So we're done going to the right.
At this time, we're going to review.
What goes to the left?
Cast of Oliver. There's been a change in the
How far do you go to the left? You
schedule
just
for
keep
tonight.
spinning
We
over?
will run all Act 2 songs from 6:30 to 7:30 and all Act 1 songs from 7:30 to 8:30. Lead vocals will work from 8:30 to 9. Repeat. We will run all Act 2 songs.
Your line gets closer
from 6:30
and
to
closer
7:30 and all Act 1 songs from
to here.
7:30 to 8:30.
Okay?
Night school will be held in room 268 today. If you jumped for cystic fibrosis,
Is this yours?
we need
It
your
is. I stole it.
budget.
All the know she's saying.
All right, so now if we want to sketch the log, or y equals log of base 1/8 of x, when you make your table of values, well, you're going to want to use bases of 8. So even though this is a 1/8, you can still do fractions. It's not that big of a deal. So we're going to go with, let's see, our x and our y's here. So if we want powers of 8, well, we know we want to use 1. Because if you plug a 1 in for x, that'll work. We also want to plug in like an 8. We can plug in a 1/8. You could also plug in a 64 and a 1/64. So if we plug in the log of 1, we're going to say the log y equals log base 1/8 of 1. So if we plug 1 in here, remember if you ever have a 1 here, it's always equal to 0. So that's a 0. So we're going to try y equals the log base 1/8 of 8. So this 8 comes over and bumps up your y. So you're going to get 8 to the y equals a 1/8 Well, this 1/8 becomes an 8 to the negative 1. So y equals -1. So if your values, if you have a fraction down here on the bottom and you have a positive value here, you're probably going to get negatives. Here, so let's do y equals the log base 1/8. Let's do the 64 first. We're going to go 64. So the 8 goes underneath. And you're going to have 1/8 to the power of y equals, oh gosh dang it. I did the 1 wrong before. So 1/8 y. Then you have a 64. So these need to be powers of 8. So this is going to be an 8 to the negative y equals 8 squared. Negative y equals 2. Y equals -2. So you're going to have a -2 here. So actually that worked out over here. I just goofed these back and forth. Alright, so let's do 1/8. So I'll say y equals log 1/8 of 1/8. So this 1/8 comes up and underneath. Then you're going to have 1/8 to the power of y equals 1/8. Well, that just means y is going to be equal to a positive 1. So you plug a positive 1 in here. This is going to end up being a positive 2. So you go ahead and graph these. So you go over 1, up 0. Over 8, down 1. Well, that's going to be over down here. Then you have 1/8, comma 1. So you go over 1/8, up 1. About here. Over 64, down 2. It's going to be way over here to the right. Over 1/64, up 2. So you're going to be right here. So what happens is this one is actually flipped upside down. So your graph goes something like this. And it follows along here. And so that's your graph. Whenever your base is less than 0, then your graph looks like this. It's flipped upside down. But if it's greater than 0, if your base is greater than 0, then you're going to have your graph similar to example number 4. Okay, you could use a graphing calculator, but you could also use transformations. So if you were to graph this, you actually don't have to use a graphing calculator, but you can make a table of values once again. And you still, even though you have a 2 and another and a -2, you can still use bases or powers of 3. Still use powers of 3. So we're gonna plug in a 1, plug in a 3. We can plug in a 3 squared, which is a 9. You could also plug in a 3 to the -1, which would give you a 1/3. You can plug in a 1/9. So we'll try these out. So we're going to say y equals 2 times the log base 3 of 1 minus 2. Well, this right here, log base 3 of 1, that is just a 0. So 2 times 0 minus 2 just gives you -2. Now if we want to plug in a 3, y equals 2 times the log base 3 of 3 minus 2. Well, log base 3 of 3, 3 to what power gives you a 3, that's going to be a 1. 2 times 1 minus 2 is 0. So you get a 0. Plug in a 9. And you're going to get, oops, we got the 2. 2 times the log base 3 of 9 minus 2. Well, this ends up being 2. 3 squared gives you a 9, so this is going to be a 2. Minus 2 gives you 2. Now if you plug in a 1/3, y equals 2 times log base 3 of 1/3 minus 2. Well, what exponent of 3 gives you a 1/3? That's going to be a -1. So 2 times -1 minus 2 gives you a -4. So if you plot these over 1 down to Over 3 up 0. Over 9 up 2, so 7, 8, 9, 2, somewhere up here. And then over 1/3 down 4 would be here. What's happening is your graph is still going up through these points, or kind of, just gotta make your point bigger. And this goes down closer and closer and closer like this. And there's your graph. Still does not cross your horizontal asymptote, or vertical asymptote, which is right here. Alright, last example. Here you have a Richter scale, and this is talking about the different, here's your Richter scale. So if you have different magnitudes, 10 to the negative 1, nothing's felt. 10 to the second, you have minor damage. Between 2 and 3, you have small damage. Between 5 and 6, you have moderate. 6 to 7, you start getting stronger, major, and great. So it has some examples of some of your different, some of your different, I can't even think right now. So your different magnitudes of your earthquakes. And if you take a look at, the scale goes up pretty high. So the largest one that was recorded used to be back in Chile in 1960. Well, last year in Japan, they had a 9.2 or a 9.0. So if we want to find the intensity of this, here's what a picture of last year in Japan would look like. Small little tidal wave just popping over the side. You can see all the little cars here just getting walloped. Horrible tidal wave that came through. So what we can do is we can find the intensity of this. So if we have y equals 10 to the power of x minus 1, and if x is your Richter scale rating, then the strongest earthquake would be 10 to the power of 9.2 minus 1, which would be y equals 10 to the 8.2. And if you want to figure out what that equaled, then you just take on your calculator 10 to the power of 8.2, and you're going to end up and get your intensity, which is measured in microns, but it's a 158,489,319, and that's listed in microns. So if it's measured in microns, it's a millionth of a meter. So a micron, you just write out 1 micron, or microns. Alright, so those are your answer for this one. So then don't forget to come in before school, after school if you need some help, and I'll be happy to help you out.